Okay, today we're going to fill in some of the gaps from yesterday over exponents. Some of the stuff should be about the exact same as before. Some of this won't. I'm just scrolling through what you're going to see. This you'll get the actual paper, or God willing, we have computers by that point in time, and then you can just kind of look at it from there. No notes, nothing new. It's just a lot of, well, you remember. Each one of these is going to have example problem. It will tell you the solution. The point of this little lesson, I guess you could call it, is to explain how you get to the solution. Some of the stuff you may be able to fast forward if you remember it from yesterday or whatnot. So our first thing we're going to look at is some of this multiplying exponents. There's about 3 different ones. There's 2 of these examples, and I'm going to show you what like number 2, 4, and 6 are kind of like, because those are a little bit different. So let's start here with this problem here. We have the 2 to the 5th times 2 to the 3rd. So let's write that in here. So here we go. We have 2 to the 5th times 2 to the 3rd. Now remember from yesterday we talked about this rule. Once the bases are the same here, these 2's are the same, for the exponents you just add them up. So our exponent of 5, we have another exponent of 3. We're going to add those 2 together. So 5 plus 3 gives you 8, and we end up with 2 to the 8th. If it's a manageable number, like 3 to the 3rd or something like that, you could go ahead and write that out. If it's a little bit higher up, like this one is a 2 to the 8th, you're more than welcome to just leave the answer as this. You don't have to give the calculated answer necessarily. So that's the first thing we're going to look at. Is this 2 to the 5th times 2 to the 3rd, and that's where the 2 to the 8th comes from. Again, you have the solution. This is just explaining how to get there. As we come back to our next example here, we have this problem off to the right. We have 5 to the 3rd, and we're going to square 5 to the 3rd. Now remember, we had a rule of power to powers. Or if you see something like this, you're going to just multiply your powers together. So the base of 5 will stay the same, and then for your exponents, you're going to multiply those at 3 times 2. 3 times 2, I hope you know, is 6. Again, 5 to the 6, kind of a bigger number, so we're not worried about, coming up with the exact answer there. So we're going to leave it in that form of 5 to the 6. Power to power. You've got to multiply your powers. Now, I'm just going to show you what number 2 looks like. We have x to the 1/6, because I know fractions make some people get very nervous. Now, the same rule is going to apply as we had on our very first example. You're going to add up your exponents. So the bases are the same. We're going to keep this same rule, 1/6 plus 2/3. Now when you get that, remember, you have to have like denominators. If you don't have like denominators, you got to get it there. So what you'll be doing is this. You're going to find the like denominator. So we got 3 and 6. The common denominator is 6. So this one will stay the same. 2/3 will go to something over 6, and then you're going to add it. If it ends up being a mixed or an improper fraction, like 16/5 or something like that, you leave it. You're not going to switch it or anything like that. I'm not going to tell you the answer. You got to fill in the rest part of it in. So, but that's what the same principle is for the fractional look. So make sure they're the same denominator when you add those two together. Okay, so that's our multiplying exponent part. We're going to skip down to the next part. Raising things to powers. Now this first problem we have here, we didn't really talk about, but it kind of goes along with some of the stuff from other sections. Alright, so we have inside the parentheses 4 plus 1 plus 7, the whole thing squared. Now make sure you don't get that confused with the powers of products rule, because this is not multiplying, it's adding parts together. This goes to order of operations, which you're going to get a review of that in a couple of days. Within the parentheses, add things together. 4 and 1 is 5, add another 7 is going to give you 12. And then you have 12 squared. Now 12 squared you can answer, that's one you can do. 12 times 12 is 144. So any of these ones here, and there's a couple in there, work within your parentheses first, then you go to the exponent. Again, that's an old order of operations rule, and that's where the 144 is going to come from. Our next problem over here on the right is this. We have 2/3 squared. Now what you do in this case is if you have a fraction raised to a power, you're going to take top and bottom both to that power. So on top we have 2, we're going to take it squared, 2 squared here. On the bottom we're going to have 3 squared. You just take each part to that power. It's kind of a power product rule with a little bit of a twist with a fraction. 2 squared is 4, 3 squared is 9. If you could have simplified it, you would have, but 4 9s doesn't simplify, so that defeats the purpose. Alright, so when you get the fraction looks, you just take each part, top and bottom, to that power, simplify. And that's where you get 4 9. Our next problem we have is this power, our products to a power. Our first example we're going to look at is 3 times 5 inside the parentheses squared. Now for this problem, you actually have 2 options. The powers of products, as this is 2 different products here, we could take 3 squared and take it times 5 squared. And then 3 squared, of course, is 9. 5 squared is 25. And then multiply these 2 together and come up with 225. That's one way you could have done this one. There is another way you could have done this, and it's back to what we did in one of our prior example. Work inside the parentheses first. If I bring that part down here, if I take 3 times 5, I end up with 15. And then I'm going to work with the exponent. And then 15 squared, you don't know it, calculate it, also gives you 225. So this problem, you've got a couple options to work with. That's the actual rule. This goes back to order of operations, which is also a rule. So either way, you've got a couple different ways to look at it. So that's how you get 225. Our next example we have here, we have 5c to the third all raised to the third power. 5c to the third all raised to the third power. Okay, 2 different products here. We have the 5, and we also have this c to the third. So there's 2 different products we're going to take to the third power. 5 to the third. Let me get back to the black here. 5 to the third. We'll also have c to the third raised to the third. So the next thing we do, 5 to the third, 5 times 5 times 5 is going to get you to 125. Now here we have power to a power, so we're going to multiply our powers here, 3 times 3, and that's going to get me c to the 9th. Put them back together, 125 c to the 9th. Each part to that power, in this case to the third power, and simplify it. That's where we come up with 125 c to the 9th. Next thing we have something more about negative exponents. Our first example problem we have here is 10 to the negative 4th times 10 squared. Now the first thing we're going to do is simplify this first. Bases are the same. The 10s are the same. We're going to add up our exponents and take negative 4 plus 2. When we do that, negative 4 and a positive 2 gives me 10 to the negative 2nd. Now, if you go back to your directions here, it will tell you do not have negative exponents in your answer. Right there. So don't do that. So when we go back to this, we can't leave it like this. So we've got to make this positive exponent. Remember to do that, you're going to flip it. So this one go to the bottom of a fraction. And remember the exponent, when you do that, changes to positive. So you are left with 1 over 10 squared. And since this one is a manageable problem, I'm going to simplify this a bit further. And 10 squared is 100, so I'm going to end up with 1 over 100. Again, either answer will work, but me being the incredibly picky person that I am, will go a little more simplified if I can do that. So that's our first example in the negatives. Our next example we have is 3x to the negative fourth raised to the negative third power. Now we're going to show you two different things we can do for this type of problem. Our first option we have is take each thing to this negative third power. We've got that. This is probably the more difficult way, at least I think. So you can take 3 to the negative third, and then we'll have this power, x to the negative fourth times negative 3. Well, 3 to the negative third here, we're going to redo this as 1 over 3 to the third. If we take power to a power here, negative 4 times negative 3 gives me x to the 12. And when we simplify this, x to the 12th is going to stay on top. And then 1 over 3 to the third. The 3 to the third is 27, so it will stay on the bottom. And this is going to be our answer, x to the 12th all over 27. Finally, the last thing we're going to do is divide some exponents here. Now, we've got a few different things we need to do for this one. We have 10 squared raised to the fourth power all over 10 to the fifth power. Now, before we get going with dividing, we need to clean up the top here. Power to a power again, so multiply your powers, 2 and 4. You're going to come up with 10 to the 8th now on top over 10 to the 5th. And at this point, you can simplify. There's a couple different things. You could either follow the rule or just know, well, there's 8 of these on top, there's 5 of these on bottom, so there must be 3 left. There's that thing too. If we actually follow our rule this time, we have 8 minus 5, that is an 8. Sorry for bad writing, I'm not cleaning it up. I'm getting lazy. 10 to the third. If you want to simplify that, I didn't in the solution, but if you want to, you're more than welcome to get that as 1,000 if that's more comfortable to you. So make sure you clean things up before you actually divide, because on our next example, or last example, we're going to do the same thing. Last problem here, we have 2 over 2 squared raised to the second power. 2 over 2 squared raised to the second power. Just like we had on the previous problem, now we're going to clean things up on the bottom first. Power to a power again, 2 times 2 here. So on the bottom, we now have 2 to the 4th. On top, we still have 2. If it helps to put an exponent here, go for it. That is really a 1. Now, a couple things you could do. Again, you can go through the rules. Another thing you can do is just go, well, there's a 2 on top. I'm going to get rid of 1 on the bottom. It's the same thing you're going to do if you do the rules. So now nothing's really on top, so we need something there. That's the 1. On the bottom, we have 2 to the third. And again, if you want to simplify this out, 2 to the third, 2 times 2 is, or 2 times 2 times 2, make sure I said it right, gives you 8. So we end up with 1/8. Either option is going to work for you. Again, this is pretty much a lot of some fill in the gaps. Do a little bit more work with it because exponents is a kind of important thing to do no matter where you're at here, algebra 1, algebra 2, and some of the other classes as well. Alright, so I'm going to take a couple of days on this, so hey, you don't have to listen to me the next day. Alright, so we are good to go.